Welcome, recruits. I'm going to begin this drill in an environment you could define as hostile territory. First, let's execute a little recon of the region. It can be as cold as 40 below, or as hot as 250 degrees Fahrenheit. And now when it rains, it comes down in buckets. There's constant vibration, more than any earthquake has ever generated. And when it's dry, you can't believe the dust storms. There ain't no picnic here. And yet, as you can see, this place endures all the fury Mother Nature can muster. Now, where can you find this piece of paradise? My dear friends, it's right under the hood of your car. That's where you'll locate the ignition control module. Now that we know where I am, listen to your old Sarge tell you the rest of the story. The ignition control module, or ICM, has a pretty simple job. It turns the ignition coil's primary winding on and off at precisely the right time. This duty is critical to drivability. Just about every vehicle on the road today has an ICM. And while they all vary slightly, we're going to focus our time today on one of the most popular, GM's DIS module that fits vehicles built from 1987 to 2003. So now you pay attention, yeah? When you turn the ignition key to start, the crankshaft begins to rotate. Got it? And that's where we find our old friend, the crankshaft position sensor. Now, isn't that something? Now, as soon as the crankshaft starts to rotate, the sensor starts sending signals to the ICM. And the pattern of these signals tells this ICM the position of the crankshaft. Okay, how does it happen? This ICM has a unique technology called fast start circuitry. And it comes in real handy during like a cold start situation, or when your battery's a little low on juice. The ICM controls the ignition system all by itself during the first few minutes. After that, the powertrain control module, or PCM, takes over by going into closed loop. Isn't that something? The PCM then sends a voltage signal through the bypass wire to the ICM. And when the ICM gets the message, it's locked out of making calculations. It does, however, continue to fire the ignition system with the information it receives from the PCM through the electronic spark control, or ESC wire. The ICM also sends important information back to the PCM, confirming the switching of the transistors connected to the coil's primary winding. Isn't that something? This constant exchange of information makes the vehicle run better. For example, when an ignition misfire occurs, the PCM keeps the coil's primary winding charged a little longer than normal to give the secondary winding time to output a higher charge to overcome the additional resistance. Got that? This is a good thing, but sometimes it can be a very, very bad thing. In fact, downright self-destructive. For example, when a spark plug wire's resistance gets too high, a plug gap gets too wide, or a coil's windings begin to short, the ICM tries to correct the problem by increasing the dwell time. As the output increases in these situations, it puts both the coil and the ignition control module in dire danger. Now remember, folks, when the coil can't discharge, the high voltage electricity it generates will take the next easiest path. Often, This path will be between its secondary and primary windings. However, it will often use the ICM as a conductor. And what do you end up with? Kaboom! That's right. That's right, recruits. Digital ash and one upset customer. So, now what's the moral of this story? ICMs are built to last the life of the vehicle in a perfect world. However, if the related components are not properly maintained, that world is no longer perfect. That's why it is important to check and replace the spark plugs, ignition wires, coils, and check for bad grounds regularly. Also check the charging system as well. That's what I said, people. The charging system. The maximum the system can handle is no more than 1/2 volt AC. That's right, my friends. 1/2 volt AC. Now listen up. When a coil goes bad, your customers could be in for a world of hurt. In fact, my mailbag is filled with letters from recruits talking about all the problems. That's why Sergeant Tech recommends whenever you change the coils, be smart and replace the ICM at the same time and vice versa. And when you're recommending an ICM replacement, do your customers another favor and recommend Wells Ammo and do the job right. Remember, at face value, we all look alike, but it's the details that separate the men from the boys. Now, let's move on to the Center of Intelligence, the Application-Specific Integrated Chip, or ASIC. This chip gives our modules the right information for each specific application for optimum performance. Look closely. Here, these are the transistors. They are the part of the ICM that takes all the heat. When we look under that transistor, we find a pure copper heatsink. That's right, pure heat-sinking copper, my friends. These heat sinks are ultrasonically welded to the backing plate to keep the transistor running efficient and cool. And these scratches on the back of the module tell you right out of the box that this ICM has ultrasonically welded heat-sinking copper. Now, when you look at one of ours or an OE, that's what you'll find. But if you come across an ICM that doesn't have those scratches, my friends, you found an ICM that is truly second rate. Now, recruits, take a gander at the thickness of this wire bond. These wires have to carry all of the current and the high voltage to the transistors, even during a heavy load. That's why we make our wire bonds even thicker than the OE. Here's something not everybody does: active laser trimming. Everybody doesn't do it because it is expensive. So what? If you want a module that performs to OE specs, it must be done. Now, I bet you didn't realize an ICM had that many internal components, or each of these components has their own set of tolerances. But as we all know, it's the sum of the parts that makes the difference, especially when it comes to performance. That's why we test run every single ignition control module we manufacture, just like it will be run on the engine to make sure the performance is guaranteed. Now that is some really cool stuff, and important too. And not enough manufacturers care to recognize that fact. This is Sergeant Tech, signing off. When we get together next time, we'll take a closer look at crank and cam sensors. Dismiss!